Hi everyone! In this video we will solve logarithmic equations using the definition of a logarithm. Solve log base 3 of x minus 6 plus log base 3 of x plus 2 equals 2. In this case we have a variable and it's stuck inside both logarithms. So we're going to use our properties that we've learned, or the rules, so that we can combine them. In this case, I have an addition sign between these two, which is the product rule, and that means that I can multiply the numbers. In this case, it would be like A and B if they have the exact same base. In this case, they are both base 3, so we're good to go. So this can be combined to be log base 3 of our A, in this case x minus 6, times B, which is x plus 2, and this equals 2. We have two options. We can use the definition of a logarithm and rewrite this now, or we can multiply the x minus 6 and x plus 2 first and then rewrite it. I'm going to choose to go ahead and use the mnemonic and rewrite this. So we end up with 3 to the exponent of 2 equals x minus 6 times x plus 2. 3 squared is 9, and we can multiply on the right-hand side using FOIL first, outside, and then inside last. The first times the first gives us x squared. The outside is plus 2x, the inside is minus 6, and the last is minus 12. Adding our like terms in the middle gives us x squared minus 4x minus 12, and this still equals 9. To solve for x where we have an x squared, we need to subtract the 9 from both sides so that it equals 0, thus giving us the opportunity to use the zero product property. 12 minus 9 is negative 21. Now let's go ahead and factor this. This is in the form where our a is a 1, so we only need to look at factors of 21. And this factors into x minus 7, x plus 3, and this is still equal to 0. Now that we've factored x squared minus 4x minus 21 and it equals 0, we can use the zero product property by setting each of these factors equal to 0 and solving for x. On the first one, we need to add 7 to both sides. So we get x equals positive 7. And on the second one, we'll subtract 3 from both sides, giving us x equals negative 3. Now in this case where I multiplied the x times the x and got an x squared and factored, there's a possibility that I got an extraneous solution. So I need to go back and verify that it's okay to put it back into the logarithm. So we're going to check x minus 6, and we're going to check x plus 2. And we'll see if either of our answers make either of these logarithms something that can't be done, an impossibility or no solution. So let's try the 7 first. Substituting the 7, we get 7 minus 6, which is 1. And we can have the logarithm of 1. That works. Now let's try it over here. 7 plus 2. 7 plus 2 is 9, and yes, we can have the logarithm of the positive 9. Let's go ahead and try negative 3, where we have negative 3 minus 6 and negative 3 plus 2, substituting it into our two logarithms. Negative 3 minus 6 is negative 9, and negative 3 plus 2 is negative 1. There is no way in which we can raise a number to any sort of exponent and get a negative. So both of these will not work, which tells us that x cannot equal a negative 3. We can't have the logarithm of a negative number. And so the answer is x equals 7. And now we're all done.